Okay, so please, any other person has any question on based on the um, time series, the topics we have done. Okay, Abubakar, please.
Uh, Good morning, sir.
Yes, good morning.
For autocorrelation, are we limited to just Ron's test and Dublin Watson test?
Yes. No, I did BG test too. Am I correct?
Okay. Yes, sir.
Yeah, I did. So we are
Yes, sir.
just
Yes.
limited to that three. I know there are other
Okay.
tests, but ones I thought we are limited to them.
Okay, sir. Thank you.
All right, Osagele, please. Osagele, your question. I can't hear you, Osagele. Your question, please. Okay. Any other question? Osagele is not talking. Any other person have a
So
question?
from the previous class, we didn't conclude on the detection and
I can hear you. You said what? Your network is bad.
test for
Maybe please
this
send
Ethereum test assistant.
send the WhatsApp. I say WhatsApp message. Send the chat. I can't hear you. Your network is breaking. Probably is your network. Somebody else has a question based on what we have done. Yes, Adijat. Adijat, you can ask your question, please. Adijat, can you ask your question? I'm asking you to unmute so I can ask your question. Adijat 180315011 matric. Okay, so any other person has a question? Kasha Madukbe, yeah, please, your question.
Good morning, sir.
Yes, good morning.
My question is, autocorrelation, is it largely time series problem or largely time series and cross-sectional data
Okay, on the autocorrelation is largely
problem?
autocorrelation is largely a time series problem. It is largely a time series problem because we are looking at the relationship between the error term at period I, maybe 2019, and the error term at period J, maybe 2020. So it precedes a time series process. It follows a time series process. So it's so common in a time series analysis and not cross-sectional. Although
How about it?
although in cross-sectional analysis or panel analysis, autocorrelation can be present depending on the nature of integration of such economy. All right. You know, when you are dealing with a panel analysis, you are considering maybe a group of WAMS West African countries or group of ECOWAS member countries that are 15. And so you have Nigeria, you have Ghana, you have Gambia, and the rest. You know, if there's a high level of integration, studies have come up, all right, that's under panel data econometrics. Studies have come up to conduct the cross-sectional dependence test. And cross-sectional dependence test is saying that there is always a uniform error associated in various cross-sections. That is, because of the degree of integration, because of the openness of the market, because of how, you know, trade, globalization, opening your economy. We are one now, you know, Nigeria and Ghana, we are one. Open this border, Joe. Why are you closing the border? Open the border. Let everybody trade together. Because of that particular incident, because of that policy, increases in integration, all right, makes such region to become one. So you will always expect cross-sectional dependence between the errors of Nigeria and that of Ghana and that of Gambia. So in recent econometrics, you will see cases whereby autocorrelation becomes a problem of a cross-sectional data or becomes a problem of a panel data because of the degree of cross-sectional dependence associated with such economies. So before, when there was no independence, when we are following the theory of comparative advantage, for those of you that are doing international economics, not trade, when we are following the theory of comparative advantage that says, oh, Nigeria, specialize in what you are producing and export. Ghana, please specialize in what you are producing, what you have comparative advantage over, and export. Each of those countries, we keep saying, specialize in what you are producing, what you are producing. That is fine. All right. In that scenario, the structure of Nigeria is different from the structure of Ghana, different from the structure of Gambia. So you wouldn't see autocorrelation persistent in such scenario. Most of their markets are disintegrated. You don't have a similar pattern. All right. They all have their own target market. Under that scenario, we say that there is no level of integration. And so autocorrelation might not be present. But now, since the advent of globalization, that people have been preaching, we are one, our economy is one, this after now, African Free Continental Trade Agreement, so many policies have come up, bilateral trade agreement, multilateral trade agreements have come up to say we are all one. Nigeria and Ghana, we are one. Look at the recent policy the president just did, trying to construct a road from Nigeria, to Niger. That is just trying to integrate the economy as one. Once that is happening, you will then see that autocorrelation can be persistent in a cross-sectional analysis because they are having similar characteristics. That is why if you look at studies in EU, for example, any study that is on the European Union, they see that EU as one because there have been so much economic integration that is existing in that particular scenario. You see, France, Germany, all of them, they are using one currency, euro. They have one central bank, European Central Bank. They have similar trade policies. Just of recent that Britain had to, exit that particular policy, but they have similar pattern. So you will definitely see autocorrelation or even all of this time series problem to be peculiar in that kind of arrangement. Same goes to BRICS, Brazil, Russia, India, China, and South Africa. Group of emerging economies that want to double their output by 2050. If you look at our BRICS, they have similar pattern. They attract the highest flow of FDI. They are among the top 10 recipients of FDI. They have industries. Their labor is cheap. So they have similar characteristics surrounding them. Same with OECD member countries. If you look at the group of OECD member countries, studies that try to examine that OECD member countries, you discover that they have similar structure. And so autocorrelation or time series problem can be persistent in that particular scenario. Same with sub-Saharan African countries, same with the MENA countries, Middle East and North African countries. All right. Same with YMU, all right. All of those regions, you will discover that they have similar structure, and then autocorrelation can be persistent there. Please, have I answered the question?
Yes, sir. Very much. Thank you very much, sir.
Yeah. So, good morning, sir. The area where we make decision under the Dominican test is not clear. Oh, sorry about that. When you calculate your Watson, you have a value, okay? When you have that particular value, I think I need to share a slide. I'm coming, please. I think I need to share a slide. I just hope this will cooperate. I think it has been cooperating. Okay, can we see the slide? Can somebody respond to me? Can you see the slide?
Yes, sir, we can see it, sir.
Yes, sir, we can see it.
All right. So if you look at this this particular scenario, you would see. Let me turn off my video so that if you look at this scenario now, you would see that we have calculated the Durbin-Watson test, for example. We calculated Durbin-Watson, and the Durbin-Watson gives us a particular value. All right. Say 1.9. No, let me say 3.5. We calculated the Watson test, and the result we have was 3.5. Now there's a need for somebody is please mute your mic. Please mute your mic, oh, please. Now I want to open the Watson test table using my Gujarati textbook. Let me locate where it is. Just 1 minute, please. Let me locate where it is. So I've opened my Gujarati textbook, okay, and then okay, so I calculated my I calculated my Dubbin Watson. We all know how to calculate Dubbin Watson. You know, you say D, all right, is equals to 2, 1 minus rho, okay, or you use D equals to summation mu T minus 1 all squared over summation mu T square. We calculated that, and maybe our result was 3.5. Okay, we got 3.5 as our result. Then I'm sharing the Dubbin Watson critical value. You will see the Dubbin Watson critical value, all right? If you look at this Dubbin Watson critical value, we have at K, okay? K is the degree of freedom. We have the N values. We have DL, DU, all right? We have another one at K equals to 2, DL, DU, and this continues. If you check up, that is for 5% level of significance. If you check other tables, you would also see other tables where you have for 1% level of significance and the rest. So assuming it is 5% level of significance we are testing for. In our data, all right, we need to know the sample size. All right, we need to know the what? The sample size. From our data, assuming the sample size is say 30, that means N equals to what? 30. All right, and then we need to know our K. Of course, K is the number of what? Parameters we have. And normally, let's assume a 2 variable regression. K is equals to what? 2. So that means if I tell you that the Dubbin Watson, a calculated Dubbin Watson is 3.5, all right, and I said, given this particular Dubbin Watson, can you make a decision on if there is a presence of autocorrelation or not? From the data, N is 30. Of course, beta 0 and beta 1 is a 2 variable regression, so K is 2. And is at 5% level of significance. I come to this table, I scroll down, all right, to where I have K equals to 2, check under N equals to 30. I will copy the DL and DU. DL is the lower degree of freedom. All right, that's Dubbin Watson lower bound. The DU is the Dubbin Watson upper bound. So I'll copy those two values. From here, what I have in these two values, okay, for DL is 1.284, and for DU is 1.567. Is there anybody that does not understand that, please? Please, if you don't understand how I got that two values, can you signify, can you unmute yourself and tell me? Okay.
Yes, I was not really understanding
Can you see the,
after you
can you
figured
see,
out the two.
okay, can you see the table? My question is, do you understand I got
Yes.
DL to be equals to 1.284, DU to be equals to 1.567?
No.
No, sir.
Okay. Now, a question is given that, oh, we've estimated our Dublin Watson, we collected the data for an economy, estimated the model, and the economy has a sample size of 30. And when we estimated the model, we found out that the Dublin Watson is equals to 3.5. All right. And the model has beta 0 and beta 1, just two variable regression. And then the question there is, using your Dublin Watson critical values, can you conclude that there is autocorrelation in this model or in this result? That's the question. So from the question, we can deduce that the sample size has been given, n is 30, okay? We can also deduce that our k is 2, all right? So if that's the case, okay, I think I can use, I can highlight. So if that's the case, I will just come to k equals to 2. Can you see this now? Can you see the
Yes, sir.
highlight? Okay.
Yeah.
I'll go to k equals to 2. I highlight that, Abi. And then my n is 30. I highlight this n equals 30. Remember, they've told us that it is at 5% level of significance. If you go to the next page, subsequent pages, you will see for 1%, for 10%, but I'm concerned about 5%. So I will trace my k equals to 2 and my n equals to 30. You will discover that I will have two values here. Can you see it now?
Yes,
Yes,
sir.
sir.
So that means from there now, my n at 30 and DL and DU is what? 1.284 and 1.567. Do you understand that?
Yes, sir.
Very well, sir.
Okay, so I'll stop. Then I will go back to my table, all right, that I'm using to make my decision. So from this table I'm using to make my decision, okay, I can see that different scenarios are reached. One, the first one says if 0 is less than D, remember D is what? 3.5. And it's also less than DL. What is DL? 1.284. If such scenario should occur, all right, what am I to do? I am to do what? Reject the null hypothesis that there is no positive autocorrelation. That means I am to conclude that there is positive autocorrelation. But if you look at my result, okay, truly, 0 is less than 3.5, which is correct. But 3.5 is not less than 1.284. That means that first condition did not hold. I cannot make a decision based on that first one. All right? That is, look at what I'm saying. For the first decision, okay, 0 is less than 3.5. But 3.5 is not less than 1.284. In that case, I cannot make a decision using that particular first scenario. What will I do? I will stop. I go to the second scenario, all right? What did the second scenario say? The second scenario says DL is less than or greater than DU, less than or greater than DU. Look at it. So DL is less than or greater than D, less than or greater than what? DU. Okay? Let me share it again here now. That is DL is less than or greater than D, less than or greater than DU. Let's check if that condition holds. What is DL? 1.284. Okay? Is it less than or equals to D? What is D? 3.5. Okay? Is it less than or equals to DU? What is DU? 1.567. No, it is not less than. So, although 3.5 is greater than or equals to 1.284, but 1.567 is not greater than or equals to what? 3.5. So this condition did not hold. I will stop. All right. And then I will go to the next scenario. What is the next scenario saying? The next scenario is saying reject if 4, all right, minus DL is less than D and less than 4. Let's look at that second condition, okay? From that second condition, I would examine that second condition, all right? So the second condition says 4, okay? 4 minus DL, all right, is less than D and less than 4. So what is 4 minus DL? 4 minus DL is what? 4 minus what? 1.284 less than D. What is D? 3.5 less than 4. So 4 minus 1.284, what's the answer? That is 2.716, okay? Less than 3.5 less than 4. If you look at this particular scenario held. Abi, 4 is greater than 3.5. 3.5 is also greater than 2.76. That means the decision for the third one held. Okay? Decision for the third one held. So if that is the case, that means, oh, sorry, please. If that is the case, that means the third one is achieved. And that decision is for us to reject the null hypothesis. And the null hypothesis is there is no negative correlation. So I will reject the null hypothesis that there is no negative correlation, and I will accept the alternative that there is negative correlation. Can you see how you make your decision based on the D lower bound, the D upper bound, as well as the D? If you check for others, it will only be achieved in one of those conditions. You can verify for the third one, for the fourth one, sorry, and verify for the fifth one. You discover that the fourth one and the fifth one will not hold. So if the fourth one and the fifth one does not hold, then it is the third one. So one of them must hold under that scenario. Do you understand it now?
Yes, sir.
Okay.
Yes, sir.
Somebody is asking, can we use D equals to 1.7? D must have been calculated first. I'm just assuming that D is 3.5. In your question, they might tell you D has been calculated. This is what is D. So I'm just making only an assumption that D is 3.5. Are we together?
Yes, sir.
Okay.
Yes, sir.
Okay. Any other question, please? So if no question, because I want to conclude on the heteroscedasticity and the consequence, please. Or I should stop?
No, sir.
No.
Okay. But
No, sir.
So, all right. Okay. So we understand this now first. Abi?
Yes, sir.
Okay. So somebody said, Elizabeth. So assuming we got a no decision answer, what would be our conclusion? Okay. So let me check the table. Okay. If we got a no decision answer, that means our result is inconclusive under that scenario. Our result is inconclusive. So we cannot say that there is no autocorrelation. We cannot say that there is positive autocorrelation. We cannot say that there is negative autocorrelation. So it's inconclusive. That is one of the limitations of the Dobbin-Watson test. Two great limitations of Dobbin-Watson test. One, we have the bounds where our decisions are inconclusive. So you don't know what to decide. That is one. Two, we have, it's only applicable to an autoregressive process of first order. But there are possibilities of we having autocorrelation for higher order. So when we have autocorrelation of higher order, you cannot use Watson anymore. So those are the two major limitations. So Lawson, please, what's your question? Somebody please mute yourself. Eh? Please, you are behaving since.
Sir, for Watson,
yes.
I think they. Sir?
Continue, sir.
For the Watson test, there were two formulas that were given to us.
Yes.
We have D equals to 2 into brackets 1 minus P.
Rho. Yeah. Rho,
and then we have
not P, it's called rho. R-H-O.
Oh, yes, P, rho.
Rho, yes.
The rho. And then D equals to the summation mu T minus 1.
Yeah.
Brackets close square all over mu T square.
Yeah.
Can we use those two formulas separately?
Okay. Now, those two formulas can be used separately. Those two formulas gives the same result. The rho there, you have to understand one thing. And what you have to understand is this. Our autocorrelation we are calculating is from a sample. Remember, a sample. When I use that example that I did in class, I picked GDP of Nigeria, gross domestic investment, and the rest of Nigeria for a specific period. It wasn't for all the period. So it's a sample. So if I pick a sample and I estimate my result, I will use D equals to summation mu T minus 1. I'll use that formula because that is for sample autocorrelation. In the other one that is D equals to 2, 1 minus rho, that rho is the correlation that exists in the population. But remember I said the genesis of statistics and econometrics is because population is large. And so if you are trying to study population, the person might die while trying because population is large. So if you can't get hold of the population, you use the second formula. But if you can estimate the correlation that exists between two populations, in a population, and you are using a population, fine. For example, if I want to conduct a study, all right, on maybe buying decision or salary, uses of our salary by academic staff in University of Lagos. Of course, the academic staff are not much, maybe about 2,000 or 118. You can conduct the sample, so you can take all the population. You don't need sample. You can do the test for the population. Under that scenario, you have to use the first one because you will see the correlation coefficient in your population. But when your population is not given, you cannot use population. You must use sample. So two of them can be independently applied depending on the scenario that you are dealing with. So if you are dealing with a population sample, so thank you for that question. You're asking beautiful questions. So when you see questions that have to do with population sample, assuming we are investigating the decision of buying behavior of blah 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 population, you should know the formula to apply. All right. Has that answered the question?
Yes, sir.
All right.
Thank you, sir.
Yeah, Temitope Johnson.
Yes, sir. Good morning, sir. Yeah. Sir, I'm sorry, I didn't get the second limitation of the Watson test.
First one is that there are boundaries, there are points that you have no decision to make. That is, your decision is inconclusive. And that is not good enough. Because when you come to a point where something tells you you can't conclude, then what should I do? That's number one. Number two is that Watson is autoregressive of degree 1, or first order, sorry. Watson follows the first order autoregressive process. What does it mean? It means Watson is assuming that there is correlation between the error term at this period and the error term at the immediate past period. So Watson is assuming that there's a correlation between the error term of 2019 and 2020, 2018 and 2019. One teller one, they are following themselves back to back. That's what Dominican Watson is assuming. But in reality, there might be situations whereby there is correlation between error term formed in 2020 and error term of 2014. Have you seen it? Between 2020 and 2014, how many periods do we have? 6. That means that is autoregressive of order 6, AR6 process. Under that scenario, Dominican Watson cannot validate if there is autocorrelation or not, because that is for AR process of 6. There are also situations whereby, there can be autocorrelation between now, 2020 and 2018. Example, look at Nigeria. If you want to look at impact of something on academic calendar of Nigerian Federal University, you will know that periods where we have strike, there's a similar pattern. So if we have strike in 2020, we did not have in 2019, we now have in 2018, then we have in 2013. That means there must be a correlation between the academic calendar and performance of students in those years that we have strike. But those years that we have strike, they are not following themselves. Dominican Watson will now be limited in testing for autocorrelation under that scenario. So Bruce Godfrey is good for higher order autocorrelation, higher order test for autocorrelation. So under that scenario, we can't use Dominican Watson. That's a limitation. So Dominican Watson is only assuming that it is following themselves back to back. But most times, scenarios or economic data, does not follow themselves back to back. It might be 2 years interval, 4 years. For example, again, and let me give you good examples so that when you see them in the exam, you won't say, this boy has done us wicked. Another example, you can see election period. Elections are every what? For 4 years. You know that because of cost of campaigning, too much of campaigning, expenses on campaigning, there will be too much money in circulation, for example, or you always have funds flying around because of paying for advert on campaigning and all of those things, all right? That means every 4 years, it will follow a similar pattern. So if you are conducting a study for election periods, 1999, 2003, 2007, 2011, 2015, 2019, 2023, under that scenario, it is for 4 years. It is AR of 4 process, AR4. You can't use Dominican Watson. Do you understand it now?
Yes, sir. Thank you very much, sir.
All right. Somebody says, sir, if we have to use the D equals to 2, 1 minus this formula, assuming our question is in relation to population, are we going to be given the value for P? Yes, or we have to solve for it. You can be given the value for P, 1. 2, you can be asked to solve for it. If you're asked to solve for it, they're asking you to find the correlation coefficient. That's it. Correlation coefficient, that's what they're asking you to find. So, but most times, not to be too straight, you'll be given that P, and you can just slot it in. Any other question on that? Any other question? Okay, so there is no other question. So thank you for this revision, and I hope the revision would help